So here we have an example of a recursive function. So let's see what some of these first three terms are. So given that f of 0 is equal to 1, and then we will use this formula to find all of the other parts of the function. Excuse me, the other terms of the function. So f of 1 is going to be, according to the definition, f of 0 times 1. Now where did that come from? F of n is f of n minus 1 times n. So if n is equal to 1, that means I'm plugging in a 1 for my function initially, and then I have n minus 1 in here, and then I'm multiplying by n right here. And that's where that came from. So this is going to give us, that's equal to, well, f of 0 is 1, so 1 times 1, which is 1. The next one would be when n is equal to 2, and we'll have f of 2 equals f of 1 times 2, which is going to be 1 times 2, which is 2. Next will be when n is equal to 3, and I'm going to, whoops, not 4, but I am going to do 4 down here. So f of 3 is f of 2 times 3, so that's 2 times 3, which is 6. F of 4 would give us f of 3 times 4, which is 6 times 4, which is 24, and so on and so forth. So I'm wondering if you have noticed what we're doing here. Look at f of 4. F of 4 is 24, but that is 4 times 6. But 6 is 3 times 2. 2 is 2 times 1. So really, 24 is 4 times 3 times 2 times 1, which should be something very familiar to us. Actually, what we found is a recursive function that gives us the values of the factorial.